Hey, in this lecture I want to discuss the global stream objects. Those are cout, cin, cerr, so cerr, and then clog. These are objects, they have external linkage, meaning that they are global objects, and they have static duration. This simply means that they persist for the duration of the program. In this table we can see standard cout and standard cin, we are familiar with those. Now standard cout is an object of class ostream, and standard cin is an object of class istream. The iOS, iStream, and OStream files are not usually included directly in most programs. As we've seen, to use the standard cout and the standard cin, we can simply include the iOStream file. One more thing that I'd like to note is that the cout and cin, the C actually stands for character, even though we call it console output, console input, and so on. For example, cerr is also referred to as the character error or character error stream because this is a stream. Similarly, cin can also be referred to as the character input stream and cout as the character output stream because these are streams of characters. We are moving characters around. Similarly, clog can be referred to as the character logging stream. A few more notes with the standard output. Any output to the stream is not immediately flushed, so we need to talk a bit about what flushing means. Firstly, we have something called a buffer, which is a region of memory where data is stored temporarily. It is basically an intermediary memory location. If data is stored in that temporary memory location, then we refer to that memory as being buffered. Data is buffered for efficiency. It is more efficient to send, or in other words to flush, all of the data at once than to send it bit by bit, or in chunks in other words. So let's say we are doing a console output statement. In other words, we have some data that is going out to some stream, and maybe the console window, the data being characters. Some events may cause the buffer to be flushed, so in the case where the user presses enter in a console input statement, or in the case where the buffer is full. And we also have some manipulators which I'll discuss later on in the lesson, but that we've seen already, such as endline. Those will also flush the buffer, and that will then send all of that data in the buffer from the buffer or temporary storage to the destination, which in this case is the console. Okay, back to our table. Now we'll see out the output is not immediately flushed. So we'll need to use some manipulators such as standard flush or standard endline to flush. I will discuss the standard flush in a bit more detail later on in the lesson. With standard cin, the input is going to be flushed because the user is going to press the enter. Cin is tied to the standard output stream, in other words cout. What this means is that cout's buffer is flushed before each operation performed on the console input. A useful thing with the standard error stream is that any output to the stream is immediately flushed. To recap, any input from standard cin or output to the standard error stream, and also program termination will flush the output stream. Basically, if you want to log something, then you can use the standard logging stream. That can be certain messages during program execution to let the programmer know that things are going as they intended, certain values and so on. That can be used for debugging and so forth. But then you can also use the standard error stream in the case where you want to log an error. For example, let's have a small program where the user is prompted to enter their age, and the user enters a negative value, such as -5. Then you can use the standard error stream to output an error message, specifying that the age cannot be a negative value. We have all kinds of stream manipulators. We have the boolean for bool alpha, no bool alpha that we've seen already. We have manipulators that allow us to display integers, the different bases on those values. So base 8, base 10, and base 16 for hexadecimal, octal, and decimal values. We also have manipulators that allow us to display the decimal point and trailing zeros, that is with floating point values. We can also display the plus, or in other words the positive sign. Typically only the negative sign, so minus sign, shows up. We can also specify a field, which is a predefined number of characters, where we want to put characters out into, and then we can justify that to the left and to the right. We can set the precision for floating point values and much more, so we will discuss those manipulators first in the upcoming lectures. We have seen examples of stream manipulators in previous lessons, so for example, the bool alpha. You can see I have the console input, the stream extraction operator, and then the bool alpha, which is going to set that bool alpha flag on the console input, and then I can do cin. Up here I have my bool, which is set to true, but I want to enter a boolean value true or false. So I do cin my bool, and then I also do console output, cout the stream insertion operator, and then I set the bool alpha on that. Then I print out my bool, and of course instead of getting 1 or 0 with this, we now get true or false, and then we can set that to no bool alpha again, and then here we should get 0 or 1 depending on whether the user entered true or false. Go and test that. I'll just pull the run. We have seen this example before, but I'll just reiterate here. I will enter true, press enter, and we get true and 1. And of course, if we enter false, we'll get false printed out and 0. Again, bool alpha is going to set that flag, and then no bool alpha is going to unset that flag again. This demonstrates that we can set flags, or that is, use stream manipulators on both the cout and the cin, that is console output and console input.